To compound interest. Compound interest is the interest on your original investment as well as any accrued interest, okay? So compound interest can be paid in times a year. So the n number of compounds per year, when semi-annually, your n equals 2. Quarterly, your n equals 4. Monthly, your n equals 12. Daily, your n equals 365. There are two formulas. When compound interest, you have formula. Your A equals P times 1 plus R over N, all raised to the NT. So you use this formula when there's an N involved, okay? You see your N here. So use this formula. There's an N, okay? Now let's look at the other formula. This is the continuously compounded. This one, continuously is your key word. Tells you to use PERT. That's what I call this guy. His name's PERT. So A equals P times E raised to the RT. PERT. So that's what this little guy says, PERT. So when you see the word continuously, just automatically think, yep, I'm going to use PERT. Okay? So here is our little example. It says you decide to invest $8,000 for 6 years, and you have a choice between two accounts. The first account pays 1.20% interest per year, compounded monthly. The second, 0.19% interest per year, compounded continuously. Which is the better investment? So, we're going to figure this out. So, let's just look at this. We invest $8,000 for 6 years. Okay, the first account pays this much interest, but it's compounded monthly. Now, the second pays 1.19%, and it's compounded continuously. So let's look at the first one. First account. So since it's compounded monthly, we know we're going to use P times 1 plus R over N, all raised to the NT, because we're going to have N periods of compound. Okay. So for this one, we're finding N. Or finding A, sorry. Finding G, finding A. So let's make us a little key over here. Our P equals our initial investment, so that's going to be $8,000. I guess you can put a dollar sign there if you want to. Now, next, our rate, our interest rate. We can never leave it in the percentage form though, so we're going to move this over to, right? So if we have, I'm going to do it up here, 1.20%, we're going to move our decimal point over 2. So 1, 2. So we're going to put a 0 here. So this is going to equal 0.0120. Okay? So that's going to be what he equals, 0.0120. What is our time? Time is 6 because there's 6 years. Our N, I'm just kind of going across here. Our N is going to be, well, it's compounded monthly. How many months are in a year? 12. Right on. Okay, and we know we're solving for A, so here's our little key that we're going to use. So now we're just going to plug these in. So I call this plug and chug because we're just going to plug these amounts in for where the letters are. So we're going to have A. Well, next thing is P, so we know that's $8,000 times 1 Well, our R is 0.0120 over our N, which is 12. That is going to be raised, well, to our N, which is 12 times 6. Okay? So we put that in the calculator. Like this. Let's get this over a little bit so you can see what I'm doing. So we have 8,000, start our parenthesis, 1 plus. Now this is a fraction, so you can do alpha y equals. Then it's going to do n slash d, which looks like a fraction, so that's what it is. 0.0120 is on top. Now you hit this little arrow key here, and that'll take you to the bottom. And we have 12. Arrow over, enter parenthesis. Now you can do your caret key, and it'll take you up to your power. I'm going to do a parenthesis, 12 times 6, and there's your answer. So it's $8,596, and of course we're dealing with dollars, so we're going to do cents, right? So we're going to round this to 93 cents. So $8,596.93 is approximately what we got. So that was our first one that was compounded monthly, okay? Now let's do our second one. Second account. So it pays. Everything about our key is going to be the same, except for our rate's going to change. So this one, our rate, we're going to move our decimal point over 1, 2, so it's going to be 0.0119. Almost forgot my second one there, sorry. And it says per year, and it's compounded continuously. So we know that this continuously tells us that we're going to use part. So it's going to be A equals PE raised to the RT. We don't have an N in this equation, so we don't have to worry about that. Everything else is the same. So here we go, plug and chug. A equals, our P is still $8,000. E is just a number, so it's just E. Our R now is 0.0119, and our T is the same, which is 6. Okay, so we put it in our calculator. So we'll say 8,000. Second division is your E. You can do second LN if you wish. I'm going to do my caret. I'm going to do 0.0119 times 6. Gives us approximately $8,592.09. So I wanted to know which is the better investment. Well, this was $8,592.09. This was $8,596.93. So our first one, when it was compounded monthly at the interest 1.20%, was the better of the two. Okay? Because this is more money. It's more dollars. Okay? Right on. So this problem has got quite a few steps, but it's a really good example because we do most of the compounds. So find the accumulated value of the investment of $10,000 for 5 years at an interest rate, of 3.2% if the money is A, compounded semi-annually, B, compounded quarterly, C, compounded monthly, and D, compounded continuously. So let's start with A, obviously. If we look at all the first three though, all of these are going to be A equals P. We know this. Why? R over N to the NT. Because they each have end compounding periods, correct? And if we look down here, this one has the keyword continuously. So we know that for this one, we're going to use A. equals PE to the RT. We're going to use PERT, okay? Figure that out right away, and that's going to make every step pretty much just plug and chug now. All we got to do is find our key. Which one just will change for our n, so we can make our key right here. So our principal is going to be 10,000, okay? Our rate is over 2, 1, 2, that's going to be 0.032. Our n, well, we're going to figure that out for each one. So I'm just going to kind of leave that blank. And what's our t? Time is going to be 5 years. So this changes for each one. It changes, because we'll do that for each one, okay? So for A, yeah, let's just do A. That sounds easy. Okay, so A, this is compound semi-annually, so we know that E is, or N is going to equal 2. Oh, I said E, sorry. Okay, so we have all of this, and our N is going to equal 2. So now we can just plug and chug. So this is going to be A, RP, well, it's 10,000, times 1 plus RR, 0.032, over, what is our N? Well, we've already said that it's 2. That's going to be raised to our N, which is 2 times 5. Or you could write 10 there if you prefer. But I'm note building, so I'm going to write 2 times 5. Okay? Well, that is going to equal $11,720, 255. Now this is dollars that we're dealing with, so let's do approximately $11,720.26. Okay? Now let's do B. So for B, compounded quarterly, how many quarters are in a year? Same as in a dollar. How many quarters are in a dollar? So our N is going to equal 4. Okay, we're going to use the same key right through my smiley face. Great sentence. So we're going to have A, once again, our P is 10,000 times 1 plus 0.032. Nothing changes there except for now our N is 4. And 4 times 5 is our power. Okay. So that equals 11,727. Did the wrong answer, sorry. 27,043. And once again, we're dealing with money. So it'll be 11,727.64. Now let's look at C. Compounded monthly, so there's 12 months in a year. And now we can just plug and chug again. A equals 10,000 times 1 plus 0.032 over 12, all raised to 12 times 5. And that's going to equal $11,732.60993. And again, we'll round that to $11,732.61. Last but not least, our PERT, which is D. We know PERT once again because it says continuously. So we're going to solve for A once more. So we have A equals our P, 10,000 times E raised to the 0.032, and our time is 5. So that is going to equal 11,735.10871, and we'll round to $11,735.11. And you can see that when it's compounded continuously, that is the highest amount that we can make. Okay, that is the end of that one. Have a great day.